Today we're going to talk about the methods of exploring data. There are two different methods that we're going to be focused on today. The first one is the scientific method. Now, the scientific method has four different steps to it. First, you have to gather information about what you're studying. Now, on the basis of the data, you have to formulate a preliminary generalization or hypothesis. So it's like you get all this data and you're like, I think this is what the data is going to mean. And then you have to collect further data to test the hypothesis. And then the final step is if the data and other subsequent experiments support the hypothesis, then it becomes a law. Okay? That's the scientific method. You guys have been doing that like your entire K through 12 education. The methods for exploring research problems that have become standards in the scientific community. So this is like a standard. This is something that the scientific community relies on. This is what you have to go through in order for something to become a law. Okay, the next method is the decision-making method. Okay? Now the decision-making method has more steps, but it's not, in my opinion, as precise. So number one, it's clearly define the problem and any influential variables. Then you have to decide upon objectives and decision criteria for choosing a solution. And then you have to create alternative solutions. Then you have to compare alternatives using the criteria established in the second step. Then you have to implement the chosen alternative, and then you have to check the results to make sure the desired results are achieved. Now, the decision-making method is nothing formal. Reoccurrences lead to generalization. So like, for example, every time I eat ice cream, I don't feel well, therefore I probably don't like ice cream. So decision-making methods are really, really informal. It's like, you know, every time I drink a glass of milk, my stomach really hurts, I think I might be lactose intolerant. There's nothing scientific about that, it's just like trial and error. Are we okay with that? Now, there are two ways to obtain data. Okay, there's two ways. The first way is observation. Okay, the first way is observation. Well, that like makes sense. You're just going to observe and you're going to take notes, and that's obtaining data. That's what we're used to. We're just going to see what happens. Okay? The second way is by controlled experiments. Controlled experiments. And to be able to do a controlled experiment, if you guys remember from science class, you have to have a control group. Okay? And then you also have to have an experimental group. Now, another word that you guys might hear instead of experimental group would be like a treatment group, what you're going to apply the treatment to. That's another word for experimental, is your treatment group. Okay? That's what you need in a controlled experiment. Again, observations, you're just sitting there and observing. You don't have to have a control group. You don't have to have an experiment group. You're just seeing, like, what's happening. Can I observe it? Can I document it? Can I come up with something for it? A controlled experiment is like, where can I make this happen? Do I have a control group? Do I have an experimental group? Now, to determine which method to use, it's dependent on the problem to be solved as well as the ethical and practical restraints of collecting data. So there are some experiments that we really want to do, but ethically probably not okay. So you guys heard of, during like World War II, the Germans performed a ton of experiments that led to a lot of scientific information that we know to be true today, but those experiments were not ethical and they probably shouldn't have done them. So there's a lot of things that we could find out for science, but we are going to have to figure out another way to find them out, because ethically we cannot do some things to humans or animals or anything else without like just having some big ramifications. Practical means like sometimes it's just not practical to do these things. So sometimes it might be like we have to have like thousands and thousands and hundreds of thousands of people to do something, and that's just not practical. Practically, we cannot afford to do that. Does that make sense? So that might be where observation comes in, but to determine which method to use, it's dependent on the problem to be solved. Okay? All right. Now we're going to get some vocab in for us. So the first thing we're going to talk about is something called confounding variables. So a confounding, C-O-N-F-O-U-N-D-I-N-G, confounding variables are extra variables that are not accounted for during experimentation and can cause some results to become skewed. So it's something like when you're doing an experiment, something comes along out of nowhere and you're like, dang, because of this confounding variable, it skewed my results. All right? Those are actually something really important. So when you think of confounding variables, like if you see data that's coming on the screen and it's like, we surveyed all of these people, a confounding variable might be like they weren't being honest. Or a confounding variable might be like they only surveyed old people because they only called them on their landlines. What about the rest of us? Does that make sense? Another thing, a next one is called a response variable. A response variable. A response variable measures the outcome of interest in a study. A response variable measures the outcome of interest in a study. So, an example of this might be like students' grade in a physics course. So what I mean by that is at the end of the year I look at all of the grades in the course and I determine if I did a good job teaching or if I need to make it better. Are we okay with that? A response variable measures the outcome of interest in a study. Okay? Next thing we're going to talk about is an explanatory variable. E-X-P-L-A-N-A-T-O-R-Y, an explanatory variable. And an explanatory variable causes or explains change in a response variable. Okay? Causes or explains change in a response variable. So, a good example of that is whether students take calculus before they take physics. So I'll explain that in just a minute. So an explanatory variable might be something like, okay, so I want to look at these kids' grades to see how they did in physics class. But I think that if a student takes calculus before they take physics, they're going to do a lot better. So if you look at all the students who took calculus before they took physics, and they all have higher grades, that would be an explanatory variable. Okay? An explanatory variable is something that could cause it. All right. The next thing you've definitely heard of before is called a placebo. P-L-A-C-E-B-O. And a placebo is just a fake treatment that has the potential to cause a response. You'll hear about this a lot in medical studies. So in medical studies, when they do a controlled experiment, they have the control group and they have the treatment group. Now in the control group, what they're doing is they are offering a placebo because they know that it shouldn't change. But, as we found in science, sometimes if people think that they are getting the actual treatment and they actually receive the placebo, it, really does help them. So a good example of this, and please don't judge me for what I'm about to say, is like in Grey's Anatomy, if you heard, or if you watched the episode or the season where Meredith Grey and Jared Shepard are trying to cure Alzheimer's. They're doing the study, and they have all of these patients, and they are administering placebos to some and the treatment group to others to see if their treatment that they chose is making a difference, is making an impact compared to the placebo group. Okay? So placebo is fake. Next, we're going to talk about something called a double-blind study. A double-blind study. And a double-blind study is used to counteract the placebo effect. Okay? So in a double-blind study, the subjects are not told whether they are members of the treatment group or the control group. The evaluators are also not told whether their subjects are members of the control group or experiment group. So again, if we go back to that Grey's Anatomy experiment where they're doing placebo in some and treatment group in others, that is not a double-blind study because the patient does not know whether they got the placebo or whether they got the treatment. And up to a certain point, like the doctors don't know either, but when the doctors open that folder, the patient's head is open on the table, the doctors know whether they get the placebo or whether they get the treatment group. The doctors know which one to administer. That is not double-blind. A double-blind study means throughout the whole study, the person who's being like evaluated and the evaluator themselves both have no idea if they have the placebo or if they have the treatment group. Does that make sense? Are we okay with that? All right. And then finally here, the last thing that we're going to talk about is bias. And bias is the tendency to overestimate or underestimate the value of a certain population parameter. Now, a bias is what we're trying to eliminate in a double-blind study. So, if the doctor knows, hey, they got the placebo, hey, they got the treatment group, they're like automatically thinking, this is going to go better, this is going to go worse. That's a bias, and we want to eliminate that as much as possible. Now, you guys have also heard the word bias in other instances, like when it comes to like prejudice and something like that. It's kind of the same thing, but it's a little bit not. Bias is just a tendency to overestimate or underestimate. Okay, let's go to the back side. Now on the back side here, we're going to talk about an experiment in which neither researchers nor partakers know into which group a partaker has been placed. Out of those vocab words that we just learned, which one do you think represents this the most? It's a double-blind study. Very good. Okay. Now, if the nurses administering care know which patients received a placebo treatment or a treatment, but the participant does not know, what do you think that would be called? A single-blind study. This is a single-blind study. So the nurses know which patient received the placebo and which ones received the treatment, but the patients have no idea. That is a single-blind study. Okay? And then finally, which group do you think received the placebo? The control group. Very good. So these right here, these questions, these examples that I just gave you, you're going to see questions like that on your Hawks Learning today. That's going to be an example of kind of what you're going to see, so just be aware of that. Now, it says, for the following examples, determine whether an observational, gosh, I cannot talk today, an observational or an experimental study would be more appropriate. So help me out here. Remember, if you need a refresher, it's on the front page. There was observation and then the experimental. So observation is when we didn't touch anything, we're just watching. Experimental is when we have the control group and the treatment group. So, on number 4, a deli cart entrepreneur wants to find out if commuters frequent her establishment often. That would be observational. She's just going to sit and watch. Observational. Okay. A car wash operator wants to find out his average annual profits. Yeah, again, that would be observational. He would just be going through all of the stuff that he's already had. That's observational. Okay? A gift shop owner wants to find out if her customer base is shrinking. Would she need to perform an experiment to figure that out? No, so what would that be? Observational. Okay? A gift shop owner wants to find out if dressing an employee in a gorilla costume will bring in more customers. That one would be experimental. You're not going to find that out unless you actually do it. Experimental. And then finally, a gas station owner wants to find out if providing a discount for local residents will generate additional revenue. Experimental.